The problem that I'm looking at today is palindromic substring. This problem can be solved in using these four approaches. You can use the brute force, then DP. You have an option to expand from the center of the string means considering each character as the center and trying to expand and make a palindrome. Then there is my Naka's algorithm. So among these I am going to cover these two in this video, and the goal of this video primarily would be to start from brute force and reach DP. So it would be a discussion on thought process of using DP, like how why once we have the brute force solution approach in hand, how we are going to optimize it and reach the DP. What is the thought process for using the DP solution? So these two approaches I won't be covering in this video. So if you want me to cover this, please mention in the comments. Okay, now we have the context set. I'm going to just start with the problem. Longest palindromic substring, and question is to given a string as find the longest palindromic substring in S. So we can note 3 points from this question. First, it is asking longest. Second, it's asking for palindromic, and third, it's asking for substring. Now I'm just going to break each of this. So substring, what is a substring? So the definition you get is a contiguous sequence of characters within a string. So given you have a string a b c d, a is a substring, ab is a substring, abcd, then bbc. So any contiguous sequence of characters that is within the string, you can say it is a substring. Now palindromic, what is meant by palindromic? Let's say you have a string abc, you reverse the string. If both are equal, it's a palindrome, it's called palindromic. In this case, abc reverse this cba, which is not equal, it's not palindromic. aba reverse this aba itself, it's a palindrome. Now longest, you have to find this substring which in this given string as which is palindromic and which is the longest one. So just being palindrome doesn't make the string your answer, it has to be longest. So let's look at the previous substrings. Here a is a single character, so it's by default it becomes a palindrome. B is a palindrome, C is a palindrome, and D is a palindrome. These are all the palindromes in the for the string A, B, C, D. Now, if you return any of this, it would be a correct answer. There are multiple correct answers in this case. Now let's look at a string B, A, B, A, D. So in this case, B, A, B. This is a palindrome, so it's obviously bigger than B. So and you can see there is one more palindrome ABA, like both are of the same size. So BAB or ABA, any of this can be your answer. Now we have discussed the basic aspect, what longest palindromic and substring, what the question is expecting us to return as the answer. Now the approaches we are coming towards. The simple straightforward thing that comes to your mind would be generate all the substrings, check each of the substring whether it's a palindrome. If it's a palindrome, note it down, like when you get the largest one, return that. So let's see the time complexity for generating all the substring. So let's have this string BABAD. If I want to generate all the substring, I can go with B, then BA, then BAB, BABA, then BABAD. Then I can start with A again, AB, ABA, ABAD. Then again this way I can start with B. So you could have as two for loops. The outer one I, then having the inner one having j as the pointer, increase j one time, then you have starting as I and ending of the substring as j, you have a b a, then increment j one more time, you have b a b, continue till the end of the string. After this, increment I once, so you would have again start from now. Starting and ending is at a itself. A is a substring, increment j. A b is your another substring, increment j again. A b a. So these are the, you are to using two loops with variable I in the outer one, with variable j in the inner one, to generate all the substring. Now for each substring you need to check whether it's a palindrome. So for generating the substring, you are having two loops. It's a n square operation, order of n square. Now second part is check if palindrome. Let's say for character a b b a, how can I check palindrome? You can have a two pointer. You can look up, there are multiple ways to check if it's a palindrome. The simplest being, you can have one pointer at the start, and you can have one another pointer at the end. You can compare the start and end character, both are same. You can increment the start, decrement the end, again compare. In this case both are same again. So at any point, if character is not equal, you can return false. But uh, if you if the all the characters are equal till and I and j coincide, that means it's a palindrome. So you start from the start, and you start another point from the end. The start pointer is going forward, the end pointer is going backwards, till the point they meet in the middle. If all the characters are equal, then you got a palindrome. So this is the simplest way to check it's a palindrome. You can look it up. So my point of discussion mostly in this video would be on the DP part. So for this approach, you would be having a time complexity of n. So for each n square, each substring you generate, you have to do a palindrome check. So one more n gets added, so you have a n cube order. This is the brute force. For brute force approach, the n cube is the time complexity. So we could reduce this. That's where dp comes into picture. Now before dp, I just want to go look at some property of palindrome. So let's take this string. This is a palindrome. You can see that for a palindrome, the first character and the last one is equal. So if if the middle string is a palindrome, and first character and last character are equal, then the whole thing becomes a palindrome. So you can look at for any palindrome. Let's say I am having a palindrome ADDA. Now if I add, now you can see this is a palindrome. Now if I add two characters, the same character at the start and end of this palindrome, let's say Z, I added at the end, I added Z in the start, so you get a new palindrome. So if the first and last character are equal and the middle string is a palindrome, the whole thing becomes a palindrome. So you can say start equal to then the whole thing becomes a palindrome. So you can use this as a criteria to check if it's a palindrome. So if you found a string with the start and end character equal and middle string as palindrome, then the whole string is a palindrome. This is the primary approach that we are going to use in the DP. So it can be written as character at I is the start pointer, j is the end pointer. If both are equal and the middle point part, the I plus 1, which is like if this is I the character, so I plus 1 start from this. So for the middle string, it start from A, which is I plus 1 till j minus 1. So you have the j here, so j minus 1 is A again, so this middle part is a palindrome, and I and j are equal, so it's the whole thing becomes a palindrome. So you need to have repeating subproblems as well. So let's take this race car again, and you can see how we generated substrings initially. The initial approach was to increment j. You initially have r as the substring, then ra when I and j is incremented, j is incremented one more time, rac. So you can say that r and c are not equal. So we can assume we don't need to check the whole thing. When R and C are not equal, the whole thing is not a palindrome. RAC is not a palindrome. Now increment J one more time. RACE, the start character and end character are not equal, so it cannot be a palindrome. Now instead of checking the whole string, we are just deciding based on the start and end. Now R RACE, now moving forward, and we reach at the end. So now J is at the end, both R and R are equal. Now the middle string, so it's a sub problem. We need to check whether it's a palindrome in itself. Because of the way we iterated, we if we had already computed this one, it would have been easy for us to pick up whether this is a palindrome or not. Because we are doing iteration in this manner, we are coming at the larger problem first instead of the smaller problem. So I'm going to change the way we are going to iterate so that we can apply DP. This is very important part. This is the part that is not mentioned in most of the videos or articles that is describing this problem. So if you are using this approach for generating substrings, it is very difficult for you to come to the DP approach. So if you have I fixed, then increment j, then once j reaches end, you increment I, then again start incrementing j from here. With this one, it is very difficult to move to DP. So what I'm going to do is let this be here. Now I'm just going to change the iteration that we are going to do. Just copy pasted it here. We have race car. Now instead of starting from there, what I did is start from the end. So I and j. So what are we looking at right now? R. R by itself is a palindrome. True. Now we have no other option. We move the I backward here and j backward here. A, we have A is true. A is a palindrome. We increment j. Now we have AR. No, it's not a palindrome. Now we go back to C. Again we start C, CA, CAR. Only this one is true palindrome. Again we go back. I is moved to here, J is moved to here. We start from E, then EC, ECA, ECAR. E, EC, ECA. Sorry, I have written D here. D, CAR. Only this one is a palindrome. In the same way, we are moving. So you can see that we each time we are computing the small subproblem first, and we are storing it. So you can store this somewhere, the results, and you can pick this up. So So now you go back to C. you, you are again coming to C. It's a palindrome by itself. CE, no. UCEC. You can see that our first character and second character, sorry, last character are equal. Now we need to check one more thing, the string in the middle. If string in the middle is a palindrome, then first character and last character are equal, then the whole thing is a palindrome. So instead of checking ourselves, we are looking at the past result. So you see that I and J are equal now. Now the only question is whether E is a palindrome. Let's look at our already computed table. Yeah, E is a palindrome. It is true. So the whole thing CEC is a true. It's a palindrome. Now you go ahead. CECA, CECAR, CECAR. All these are not non-palindromes because the first and last character are not equal. Instead of checking the whole string, we are now able to decide at checking at C and R it's not equal, and we know because it's not equal we don't need to check inside, or we are able to decide with checking the only the starting and end part. Now we go back to I to A. You can say that A it's a palindrome, AC no, ACE no, ACEC no. Now when we are at A, CE, CA, you can see that A start and J end both are equal. That means we need to check whether CEC is a palindrome. Instead of checking character by character again, previously we have encountered the same subproblem somewhere and we marked it as true. So we only need to pull this up result. So when you pull the CEC, it is true, and these two start and end characters are true. So this whole thing is a palindrome. So in this iteration we get C A C E C A true. Now if we iterate back, start from I, you can increment R A R C R A C R A C E R A C E C R A C E C A R and R. You can see start and end are equal, and A C E C A. We need to look up instead of computing again. We have already stored previously that ACECA is true. So you can get the result from there. So your start and end characters are equal and the string in the middle is a palindrome. So that means the whole thing is a palindrome. So you can see when we change the iteration, if you start at I and J, you won't be getting this. So in this case, as we move I and J apart, we have already solved for the smaller subproblems. So instead of solving the smaller subproblems again, we can pick it up from our stored result. So when you are using a DP, instead of storing it as characters, you could do one thing. So you could do it as a table. So in CEC, instead of CEC as true, you can do create a table with what C. The index of C is 0, 1, 2. 2 comma a string starting at 2 and ending at 4. You can put 4 equal to true. So instead of storing the string and the value true, you can do that as well. Create a map and create a string, key as string and value as a boolean, like this one in Java or dictionary in Python. String with, then you can do that, or you can create a table, boolean 2D array. So basically, you can create a boolean include array dp. So you can have this. Now once you got the result that the string starting at 2 and ending at 4 is true, you can do dp of 2 4 equal to true. Now once you are at for once you are iterating at each point in I and j, you can look at if character at I equal to character j, and you need to see the inner part. So dp of I plus 1. So if this is I, you have to find the inner string. So the starting of the inner string is this is I plus 1 and it is ending at I j minus 1. I plus 1 j minus 1. So if the value from this uh, table is true and your start character and end character are same, then that means the current substring you are having, it's a palindrome. You can put I comma j equal to. So in this way, once you compute the smallest subproblems, you are storing it in the 2D boolean array that you have created. And once you expand your search space by moving your I start pointer from here to here, from end to start, and j pointer each time, this this I pointer would be the outer loop and j would be the inner loop. So if you traverse this way only, then you can apply the dp, you can use the dp, because the first traversal was like you keep I here constant and you increment j forward, then you increment go to the outer loop and increment I, then again you start from j here and increment. With this one, the issue is you are not coming to the sub problem initially. You have to solve the smaller problems first, then use that result in the bigger ones. So in this approach, the problem is that let's look at this once more. You start from here, which you solve for R, then you solve for RA, you solve for RA. Now you are at RA, you solve for RAC. Now J is incremented by RACE. Now you have the start character R. Okay, let's go further. RACE, RACEC, RACECA, RACECAR. When you are at the end, you find this start character and the end character equal. Now you want to look at the middle, ACECA. Now when you are looking at your previously calculated sub problems, so all this one you have calculated, this is true. Now all the below ones are false till this point. Now the last one, this is the one we are looking at right now, start equal to end, and you are looking for this sub problem ACECA. So all the sub problems still solved this till this point. There is no sub problem with for this one. So because we use the iteration in this manner, we are we are we haven't solved this sub problem that we need at this point. But when we you are moving the pointer in this manner, whatever sub problem you are encountering, you might have already solved in the past. That's what we saw in this approach. So this is a very like important fact. With small difference, you may know, if you are thinking from using the loop in this perspective, it is very difficult for you to come to the dp approach, because you are not seeing like the subproblem you are looking for which is not already solved. When there is no repeating subproblems, then you cannot apply deeply DP. But in this case, by just like tweaking the looping part, you realize that you can apply DP. So if you are at an interview, you are starting from this point, you would end up stuck here because you won't be able to go forward, like forward. Wouldn't become very intuitive to apply DP. So I just want, this video is all about highlighting this part, how you have to loop. So you have to start from the end so that you can use this approach. Both I and j, I has to, you have to start the outer loop variable from the end, then you go backward, then each time you can start j. For j it doesn't matter, j you can start from the I itself. For in both looping, you can, once you move I, start j from j equal to I, in that manner only. So I haven't gone through the complete code for this problem in this video. I can, if you want, I can post another video with full code, complete code for this one, for this DP approach. But this video was mostly about highlighting the different looping parts. If you don't, if you go this direction, you would be at a dead end. You would get stuck. So this was the whole point of this video. And if you find my explanation interesting, I can cover the other approaches also. Okay, thank you.